So take this problem using frequency response. Suppose if mentioned in the question frequency response, then only use the concept of frequency response. Otherwise use route criterion table, which is easy to understand. Yeah, basically route criterion might be challenging here because you have 2 e power minus s. Yeah, this here you can use only frequency response mostly. It is 2 e power minus by 5s plus 1 whole square. So what is the answer? So what you should do is, what is open loop transfer function is equal to Kc into 2 e power minus s by 5s plus 1 whole square. So phase angle of so if you expand phase angle of Kc minus, so this is 0, this is 0. Phase angle of p power minus s is minus omega c plus 2 tan inverse of minus 5 omega c, which is equal to minus pi. So can you solve what is omega c? So what is WC that you got? Point 622. You have to do trial and error here. Maybe radians per second. Now, what is the, so for stability, or first find out, let's say, for verge of stability. For verge of stability, amplitude ratio of Kc into 2 e power minus s by 5s plus 1 whole square, which is equal to 1. Kc into 2 into amplitude ratio of e power minus s is 1, which is 1 by 5 square omega c square, which is equal to 1. So what is Kc? 1 plus 25 into omega c is whole square divided by 2.
बाथरूम पे कमा 2 निमिஷம் கால் பண்ண
இது கடிலாம் வச்சுக்கலையே, இதுக்குலாம் வச்சுக்கலையே.
So what is the value that you are getting? 5.49 or 5.34. So omega c is equal to 0.622. So Kc is equal to 5.34, which you call it as, let's say, Ku. This is called as Ku, which is called as ultimate gain. That means gain at which the system is verge of stability. This is called as ultimate gain. Suppose in the next time if somebody asks you to calculate ultimate gain, how do you calculate ultimate gain is nothing but when you equate the amplitude ratio to 1. Now we will calculate Pu, which is called as ultimate period. Ultimate period. How do you calculate is, what is the time period corresponds to this frequency? How do you calculate? W equal to 2 pi f, but f equal to 1 by t. So W equal to 2 pi by t. So 2 pi is t equal to 2 pi by omega. So this is called as time period of the wave. So here 2 pi divided by 0.622. So we'll call it as ultimate period of oscillation. These two will be the above two are inputs to Ziegler Nichols settings. So how you are unmuting yourself? Don't do that. Yeah, so next problem or next concept, gain margin and phase margin. Gain margin, phase margin. So these are the two terms that we will define only for the stable systems. Gain margin and phase margin are something that we will define for stable systems. One. This is 180. This is theta. This is A. See the direction of arrows. So this is actually what is these two plots is. This is amplitude ratio versus omega. This is phase angle versus omega. So for any open loop transfer function. So take the open loop transfer function and do these two plots. Clear? Now, what does it tell you is, so just go by this rule, equate the phase angle to minus 180. At that phase angle, calculate the frequency. What do you call this frequency? What do you call this frequency as? What? Crossover frequency. Crossover frequency. At that phase angle, calculate the amplitude ratio, which is, let's say, A. Then 1 by A is called as gain margin. Is it stable system or unstable system? The one that you are seeing on the board, is it stable or unstable? Stable. How do you know it is stable? Because if I equate the phase angle to minus 180, at that frequency, if I calculate the amplitude ratio, that amplitude ratio is less than 1. So here, A is less than 1. A is less than 1. Now, what is phase margin? Phase margin is reverse. Equate the amplitude ratio to 1. Calculate the frequency. Do you call this as crossover frequency? No, this is some frequency. So here direction of the arrows is wrong. So equate the amplitude ratio to 1 and calculate the frequency. At that frequency, calculate the phase angle. This is theta. So the difference between these two, is what is called as phase margin. Is called as phase margin. The difference between these two is called as phase margin, which is theta minus of minus 180 is called as phase margin. So for stable systems, is your gain margin greater than 1 or less than 1? For stable systems, gain margin is greater than 1 and phase margin is greater than 0. Because if your theta is more than, or let's say less than minus 180, then what happens is the angle becomes, or phase margin becomes negative. Suppose if theta is, let's say, minus 150, then what is your phase margin? Minus 150 minus of minus 180, which is plus 180, which is 30 degrees. So what is gain margin is? Gain margin, equate the phase angle to minus 180, calculate the frequency. At that frequency, calculate the amplitude ratio, which is A. So that A is called as the gain margin. That A is amplitude ratio, but 1 by A is called as the gain margin. 1 by A is called as gain margin. What is phase margin is? So just remember these procedures. So write this problem. The crossover frequency, associated with a control loop employing a proportional controller to control the process represented by a transfer function is found to be assume that valve and measurement transfer functions are unity. The time constant tau is second person. If the control loop is to operate at a gain margin of 2, the gain of the proportional proportional controller is So what is the answer that you are getting? What is you are getting for tau? You will get 5.39. So what do you get as Kc? 2.85. So how do you calculate? So what is crossover frequency is already given 0.6. So what is crossover frequency? First thing is you have to frame the control loop. So it is a proportional controller. Here the valve and measurement transfer functions are given as unity. Sometimes they doesn't mention anything about, let's say, valve and measurements. Even if nothing is mentioned, you should take them as unity. Sometimes they will say that they are instantaneous, meaning also transfer functions are unity. What is meant by instantaneous? X is equal to Y, immediate. So Y, X. So what is open loop transfer function? Open loop transfer function is Kc into 2 e power minus s by tau s plus 1 whole square. So what is phase angle of Kc into 2 power e power minus s by tau s plus 1 whole square, which is equal to minus 180. So phase angle of Kc plus phase angle of 2 plus phase angle of e power minus s plus 2 into phase angle of 1 by tau s plus 1 is equal to minus 180. So what is phase angle of KC? 0. What is phase angle of 2? 0. So what is phase angle of e power minus s? You can do it in two ways. If you want to solve in radians, minus omega c minus 2 into minus tau into omega c, which is equal to minus pi. So substitute omega c and get the value of tau. If you want to solve in degrees, then you have to solve in degrees. But remember, when you are solving in radians, your calc should be in radians mode. So after this, it is a trial and error method, or let's say no need of trial and error also. What is minus 0.6 minus 2 into tan inverse of tau into 0.6, which is equal to minus pi. So what is tan inverse of tau into 0.6 is equal to pi minus 0.6 divided by 2. So tau into 0.6 is equal to tan of pi minus 0.6 divided by 2. So what is tau? But here calc should be in radians. So or else you have to solve minus 50.32 into omega c minus 2 tan inverse minus equal to minus 180. So here calculus should be in degrees mode. So tau into 0.6 equal to tan of 180 minus 57.32 into 0.6 divided by 2. Here calculus should be in degrees mode. Tau is equal to 5.39. Now, what is given? Gain margin is given as 2. So what is gain margin? 1 by A equal to 2. What is A? Amplitude ratio at the rate of omega c. So what is amplitude ratio? Amplitude ratio of open loop transfer function Kc into 2 e power minus s by tau s plus 1 whole square. So what is this one? Kc into 2 into 1 divided by root of 1 plus omega c square tau square, which is equal to, which is what is A. So this A is equal to 1 by 2, no? From this one, what is A? 1 by 2. Just substitute A equal to 1 by 2. So what is Kc equal to 2.85. So write this problem. Consider the following transfer function consider the following transfer function First question, what is crossover frequency? Second question, for the computation of Ziegler Nichols settings, the ultimate period and ultimate gain are So here, if you remember, the transfer function only given for the process. How do you find the loop, control loop? So first thing is you have to frame the control loop. So it should be proportional control. Always you do calculations for the proportional control. Since valve and measurements are not given, you can take them as 1. This is the control. So you do all this ultimate gain and stability calculations for the proportional controller only. Now you solve what is crossover frequency. What is the answer? Omega C is 0.5. We will solve one problem on phase matching rate. Yes, frequency response is always open. Then what is KC is? You have to equate the amplitude ratio to 1. Then what is amplitude ratio of open loop? 1. So which is KC into 5 0.5 square 2 square whole power 4 is equal to 1. So what is Kc here? Four by 5. 0.8. Then what is Ku is 4 by 5. What is Pu? Which is time period of oscillation. Which is W 2 pi by WC 2 pi by which is 4 pi. What is next topic is Ziegler Nichols settings. Proportional control. Can you hear my voice? I am speaking little. Proportional controller, integral controller, and PID. So can you hear my voice? Are you getting my voice? Okay. So what is next topic is from Ziegler Nichols settings. Kc, tau I, and tau d. So 0.5 Ku. You have to remember all these things. 0.45 Ku. Pu by 1.5. 0.6 Ku. Pu by 2. Pu by 8. Where do you get this Ku? You will get from the frequency response. So what are you doing is, suppose just look at this scenario. Even though my K is stable up to 10, but in the plant, this is the final that will go to the plant. Ziegler Nichols settings is something which goes directly into the plant. So even though my see Ziegler Nichols settings is something which goes directly to the plant. So look at this one. Even though my K is stable up to 10, but I cannot use more than 0.5 kV. That means this is what I told you in the starting, no? So after calculating table, you do the analysis, you get some value of Kc. But in the plant, when you are going, you may not use the full value of Kc. You may use maybe less. But you do all this analysis using a proportional control. That is why when it comes to Pi, you still further use only 4.5. When it comes to PD, you will use, let's say, 6. Let's say my Ku is 10. Then up to 5 only will use in the plant. If it is a proportional control. If it is Pi, I'll use 4.5. If it is PD, I'll use 6. If you see, I have not written PD. That is why you will never use differential controller alone in the plant. Yeah, it is important gate point of view. So just write this problem. The ultimate period of oscillation, the value of ultimate period of oscillation, the value of ultimate period of oscillation, three minutes per cycle, 3 minutes per cycle, and ultimate gain Ku is equal to 2. Ku is equal to 2. Select the correct set of tuning parameters. Select the correct set of tuning parameters for PID controller. For PID controller using Ziegler Nichols settings. Using Ziegler Nichols settings. So for PID control means you have to, what is the Kc? 0.6 into Ku. Tuning means these are the values that you are using in the plant. This is the maximum that you can go, which is 1.2. Tau I equal to, just see the table. Pu by 2, that is 3 by 2. Tau D equal to 3 by 8. So I have some more problems. With this one, basically the frequency response is almost completed, but I have 2-3 problems more. So maybe we will continue to discussion tomorrow. So I have one more problem basically, but tomorrow I will use that as a starting problem, because starting I need to solve one problem so that everybody will join. So we'll class the stop now. Tomorrow we will continue. If you have any doubts, we will take the doubts.